Hi guys, this is Bruno Gobato. Welcome to another student request video. These student request videos we record in a more not professional way. We try to be as quick as the students has doubts, so we do not edit this video. So we're going to show in this video how we can draw and design a implant using a 3D file. Okay, I'm going to show here. We are going to draw and design a reverse total shoulder arthroplasty, the glenoid part. We are using a CT scan that we have downloaded from our patient, a patient that had a reverse total shoulder arthroplasty. This implant is the Exactech implant. I'm going to open here, Exactech reverse total shoulder. This is the Exactech implant, and we are going to show how we can draw and design this kind of implant. This implant is a little bit different from others. As you can see here, the central pin is not in the center of the glenosphere, of the base plate, and so the offset is different, and the size of it's not actual cylinder, it's oval. So, but it's very easy to do as well. We will have no problems. We can do just drawing, but we can do using. I'm going to show in this video how we can use the implant as reference. So you can see here, these are the implants we have created from the CT scan. We have many videos in our platform in Udemy showing how we can create a 3D file from a CT scan using Horus, Invesalhos, and many other softwares. So this is the actual implant. So you can see this is oval. The central pin is not in the central part, and we're going to use this implant as reference. We could use actually the actual implant for planning, but we always prefer to use our designs because they are more clean, they are more easy to work on. So here we have the glenosphere and the base plate. We are going to first start on the base plate. As you can see, the base plate is oval. Okay, it's not that difficult to design an oval implant, but I'm going to show a more easy way where we can create almost any shape. So we're going to click on this right point and click curve. We could do an oval or an ellipse, just like that. We could do an ellipse. This would be perfect. This would be very easy to do, but I'm going to do in a more in a different way, a more step-by-step way. So I'm going to change the curve here on the right top's left top, and I'm going to point and click over the implant, around the implant, just as I want. So we know that here we have a flat part, and now here we have the round part. So we are pointing and click over the implant here in the front view, as you can see. Point and click, okay, and okay. Now we have created here, as you can see, a oval line. Okay, here in the perspective you can see. Let's move this oval line just above our implant, and now we are going to extrude it. We are going to create a 2D dimension to a 3D. So we can go to solid, extrude, planar curve, straight, and just click here. So we can see, we can extrude the way we want. It's not in one direction only, so it has. So we're going to extrude to the higher part of the implant. That should be just right here. Okay, we know that we have some different here. we're going to cut in the other part of the video. So now we almost have our base plate. Let's design the peg. Okay, let's select here solid, cylinder. This is the center of the peg. Okay, let's go over here. I'm not so sure the diameter, but we can adjust it later. There's no problem. So here we have the diameter, the length of the peg, just as in the correct length. And now we can look from here. We can see the correct diameter. I think we are pretty much close to what is the diameter of the peg, as we can see here. So now we have the peg, okay, and now we have the central pin. We should create a central pin guide. Let's change the color to green. Solid, cylinder, a cylinder just in the middle. Okay, so I overclicked. Here we have our central pin guide. Okay, we are almost done. Now we could cut the implant in order to be just as the original. So let's draw a square. Okay, let's draw a box here. Over the implant, we're going to draw in this view, just like that, and can be no problem. Now we are going to put here. Let's move around there, and we are going to angle it just as close enough. Here we can see just as close enough to the real implant. Okay, I think we are very good. We are very okay. Let's just move a little bit more like that. Now let's select our implant, solid, difference, and selecting the cutting object. And now we have here our object, as you can see, with this part cutted. Okay, we can do this with this part, but I'm not going. This is very simple and very small. And here we almost have done our implant. If we want, we can draw the location for the screws. Okay, let's do it. Let's select another color, solid, cylinder, and let's zoom here, and let's draw here a screw. Once we have one screw position, it's just copy and paste and move to the location we want. Okay, so here now I'm going to delete the implant. I'm going to delete this line, and here you can see that we have our implant designed. We have the base plate in the correct dimensions. We have the central pin, the peg, the central pin guide for the location, and the screws we want. In order to design the glenosphere, it's not that difficult. It's a simple sphere. Let's do it. Let's first measure, analyze. Let's measure the diameter. The diameter is 38, so we're going to create a 38 sphere. Let's change color to green. Green is okay. Solid sphere. Let's select right here. 38 diameter, 19. Okay. Now we have our sphere just as the glenosphere. Okay. And now we just have to cut in half this sphere, just as we did for the other part, just as we did for the base plate. Solid, a box. Let's draw a box over this plane here, and let's okay, now actually let's do just like that, and let's cut the sphere right there. So let's select the sphere, solid, Boolean difference, select the square, and now we have our sphere cutted. Now we just have to move it to the central pin, so we can use this cylinder as reference because this will be in the central. It's not in the central pin, so we should move to the center of our oval base plate, and here we have, I think we are done. Let's delete that. Let's group all together, and here we have our Exatec reverse total shoulder arthroplasty designed in 3D, and we can use it for any of our plans. So this is a very simple way. You look that in very in some minutes we can design. Of course, we could check for if the diameter is correct, the position is correct. I think we should move a little bit here, but this is just for tweaking and making it right for planning. So thank you for watching. This is another student request. I hope I have all the doubts are clean. Bye bye.